So in this video, I want to explain the volute pump casing and how that works with this type of velocity pump. And so in this particular case, this right here is a representation of the impeller. You can think of the impeller kind of like a propeller of a plane. The impeller is basically the internal portion of our pump that spins. Right? And so in this case, as this is spinning, water is drawn into the eye of this impeller, right? So it's drawn from you watching this video toward this diagram here. And as it's drawn into that impeller, it then hits that impeller and it's then thrown off in a horizontal direction. So water comes in toward that impeller, is thrown off outward, right? As if it were to hit the screen, right? Just like it would hit the screen, it hits that internal impeller there. It's thrown outward. Now, as this water is thrown outward, that water is sped up, right? The speed of that water becomes close in velocity to the speed at which the impeller is rotating. So that water is sped up. Now, as that water speeds up, it then hits the casing of this pump, right? The pump housing on the inside. As that water sort of smashes into that casing, it then slows down, right? And so that water then continues to travel in this circular direction here, you can see with my cursor. And as it continues to travel in this direction, you notice also that the diameter of this pump casing increases. Right? This increasing diameter is what we refer to as the volute pump casing. So as our diameter increases, right, that area of this increases, we also end up with a decrease in velocity. Now, going back to Bernoulli's principle, a decrease in velocity is going to result in an increase in pressure. So the pressure in this pump casing is increased twofold. It's increased as it comes off of the impeller and smashes into the walls of this pump casing. And then as it travels through this volute pump casing, that area expands, the velocity decreases, and therefore the pressure increases. So the water now that leaves this pump now is at a lower velocity, higher pressure.